You're watching the free version of SynthEyes Essentials. For projects and footage, head to BorisFX.com for the premium download. Hey, welcome back to the second part of mesh generation inside of SynthEyes. In the first part, we put all the pieces into place, but now it is finally time to generate that mesh. But we are still running short on trackers in this region of our image. Good thing we didn't clear out our blips. Let's go to the trackers room, and in the menu bar under trackers, select the very first entry, add many trackers. Another SynthEyes menu with a lot of options. So what is this all about? Think of this as peeling additional trackers from our blips after you've already done your solve. In the tracker requirements, we can define what kind of trackers we want to be peeled from the blips. In our original settings, we went with trackers that were 50 frames or longer, so let's drop the number to 35 to give SynthEyes a bit more options. Notice that this will change this number over here, representing the maximum number of available trackers. Can we all agree that we don't want thousands of trackers in our scene? Okay, glad we all think alike. So let's refine this a bit further. I'm not too concerned about the error rate, as we are going to create zero-weight trackers, abbreviated to ZWT. Wait, what? Zero-weight trackers are trackers that will not contribute to the solve. That will make sure that we don't mess up our already good solve with bad data, but we will still get points in 3D space that we can then use to triangulate a mesh. I reckon we don't have a lot of corner trackers in this shot, so I will not bother with the tracker type and leave this on either. Last but not least, we can adjust the number of desired trackers. Let's pick something reasonable, like 100, and also let's pick another color to distinguish our newly created trackers. How about some eggplant in here? Click Add, and our trackers are all over the place, but nowhere near where we need them. Okay, let's undo this, and then let's do a lasso selection around the area we need to add some trackers to. And now we can open Add Many Trackers again and click this little checkbox here, only within last lasso. Let's leave everything the way it was and hit Add again. Finally, we're getting somewhere. Just as a precaution, let's also run the Coalesce Nearby Trackers dialog, so that we don't have different trackers inhabiting the same space. We could define a minimum distance for all trackers, but let's stick with the defaults. As we only got automated trackers in this scene, the supervised tracker checkbox doesn't apply, but I also want to include trackers that inhabit the same space at the same time. Let's hit Examine, and SynthEyes will tell us the number of trackers that will be eliminated, and it will also highlight them red in our camera viewer. Hit Coalesce, and our deed is done here. We are getting more detail, but the top of the dune could still use some more trackers. Once again, pat yourself on the back for not clearing out the blips yet, because we are actually heading back to the features room and cherry-pick some additional trackers from those blips. But the way this looks now, I can't tell blip from blip. How are we supposed to choose the ones that will really help us along? I want to draw your attention to the section down here, the blip display preferences. Check minimum trails enforced, and now SynthEyes will only display blips that are at least that long. Play around with the value until you have enough blips there and then select Peel. With Peel activated, you can now go through the blips and click all those that you want converted to trackers. And don't forget to shuttle through the scene, as you'll miss a lot of good points if you stay on a single frame. Remember that once we refine the shot, these relatively short trackers will turn into 3D points, living there for the entirety of the scene. Unlike with what we did in the Add Many Trackers dialog, those are not zero-weight trackers, but our regular automated trackers. So they will not show up as solved points until we either refine our solve or turn them into zero-weight trackers. If you want them as zero-weight trackers, just right-click the green rhombus you created by peeling, and then select Attributes, Zero-Weighted ZWT. But maybe these guys will be useful for refinement, so I will keep them as they are and head over to the solver room. Here we can check the Calculate Distortion checkbox and run the Cleanup Trackers dialog. Make sure to uncheck the Unsolved Behind checkbox. If you leave this on, All your meticulously peeled trackers will be flushed down the drain. Also, if you want to be able to return to either the features room or the Add Many Trackers dialog, then don't clear out the blips. After that, let's refine our scene. Isn't it lovely how our lock points are doing their job? It's worth mentioning that the position of the zero-weight trackers is also recalculated, but only after the solve itself is done. If you see any subtle jumps in the point cloud, there's your reason. Shuttle through the scene and see if you really have got enough trackers to build a mesh. If not, then rinse and repeat. But I'm happy with the point cloud we've got here, so let's head to the 3D room and eventually generate this mesh. But first we need to talk about navigating and customizing the 3D room. There are a couple of little things bothering me, so let's start by going to the scene settings to bring down this tracker size. Now that's better. I don't know about you, but having the ground plane visible in the perspective view is more distracting than worthwhile in a scene that has nothing close to an even ground. So let's turn it off by either pressing G on the keyboard or by right-clicking in the perspective view and in the grid menu disable Show Grid. With a clearer view I can see my eyeballing was good, but not great. This blue line resembles the horizon line, and that is clearly not on the horizon in the image. Let's adjust that. But wait, what about our constraints? The luxury of our lock points is that they are not bound to any absolute value like x, y, or z equals 0, so they are a bit more flexible. Let's go to Window in the menu bar and bring in a floating constraint points window, just to show you how our constraints will react. See what happens if I select Whole and then use the Rotate tool to adjust the horizon line. Those clever little constraints just move along with the flow. Something to keep in mind when choosing a method to apply a coordinate system. There's one more housekeeping item I want to address. As we showcased so many different ways of adding trackers, our color coding is not really working that well anymore. I'm quickly gonna lasso select those trackers and reintroduce the original 3 colors we had for the lighthouse, the foreground, and the background. Let's talk a moment about viewport customization. SynthEyes already ships with all these layouts, and still, there will be instances where you want to modify stuff to fit your workflow or the task at hand. So for what we are going to do next, I want to stick with a quad layout, but I want to have just the top and left view and then 2 perspective views. That way I can freely navigate our scene while still being able to look at the scene through my camera at the same time. So let's set this up. Do you see the small gray wedge here? Click it and choose Perspective B to establish a second, independent perspective view, and then change the top right viewer to show the left view. If we take a look at the Layout pull-down menu, we can see that SynthEyes created a new custom layout for us, called Custom 1. Imagine you don't want to reconfigure this each and every time, so if you're happy with that layout, choose Window, Viewport Layout Manager from the menu bar. Double-clicking Custom 1 will allow us to give this a more sensible layout name, maybe Mesh Generation. When you click Save, you can save them here, and henceforth you will have your own viewer layout at your fingertip each and every time you mouse SynthEyes. It's time to get our bearings inside our newly created layout. If you are using a 3-button mouse with a proper wheel, that is probably the most intuitive way to navigate those viewers. Holding down the left mouse button will allow you to pan, while scrolling the mouse wheel will zoom in and out. If you hold down Ctrl, you can rotate, while holding down Command on the Mac or Alt on the PC will make your camera look at the scene. Play around with both modes. The key difference is that they rotate around a different pivot point. If you get confused by those hotkeys, then consider this bar up here, which you can turn on and off by pressing Mouse here. You can press and drag each function and the viewer will move accordingly. The first 4, Pan, Look, Orbit, and Dolly, are proper 3D movements, while Pan 2D and Zoom are merely 2D adjustments to the viewer, so no parallax change. 2D movements will be indicated by the red border. Scrub is kind of cool because you can just click and drag through your timeline. Render will allow you to render a play blast from that viewer, but let's leave that for our class on export. And lock? Well, that will do the same thing as the L key, lock your viewer to the camera. As we already have that view in the bottom right viewer, we are not gonna do that. But with all those, you'll still find it easier to navigate directly with a mouse. Still, it's great to have these buttons here if you're in a pinch and working from a touchpad. Let's bring up the hierarchy view as a floating window and collapse our trackers to see what kind of elements we have in our scene. So there's our camera with a mask ML mat for the sky attached, as well as a box standing in for the lighthouse. So let's rename this box to Lighthouse by double-clicking. Now, in one of the 4 viewers, let's click anywhere and press Alt-A on a Mac or Control-A on a PC to select all trackers. Next, we are going to need our mesh HUD. So if it's not visible, select Mesh from the toolbar, and then select Convert to Mesh. 2 things change. A round dot appears below each of our tracking cones here, and in the floating hierarchy view, a new track mesh appears. The little dots are vertices belonging to that mesh, but right now, the mesh only consists of vertices, but no faces. So we will need to create those faces. We already did that in class number 6 with the forest floor, but let's explore this in more detail. Just clicking triangulate will just give us a mess. Notice that with this layout with 2 perspective views, we have to be very mindful in which window we press triangulate. We can be in the desired bird's eye view for this in the bottom left viewer. If we press triangulate here, it will still give us a very weird triangulation because it triangulated from the camera's locked point of view. Regardless, with all points selected, we will end up with a mess, not a proper mesh, as the top parts of the lighthouse should not be part of that mesh. Let's undo to the moment before we generated the mesh. As we now created vertices from all the trackers in our scene, we want to make sure to have lasso vertices selected down here and not lasso trackers. It might look like the same thing, but as the trackers are not part of the mesh, selecting them will get us nowhere. So lasso vertices it is. And now we can start lasso selecting vertices to then triangulate faces from. And I would advise a divide and conquer strategy here. Select the bunch that you feel are best triangulated from that viewing angle and then hit triangulate. Then go to the next bit and select a bunch of vertices, ideally with some that are already part of the mesh we are building. Adjust the perspective camera some more and hit triangulate again. That way, you will not have to shoehorn too many vertices into a single camera angle. We also have got the ability to create individual triangles. On these border areas, this can be quite helpful. Make sure lasso vertices is still active and that no vertices are selected. If some still are, just click anywhere in the gray area to clear the selection. Select Assemble Mesh. Now start by clicking one vertex, then the second vertex, and finally the third one. There's your triangle. As a last tip, I will show you how to delete faces. Let me switch on solid meshes. That way it is easier to see what is going on. Lasso select around the 3 vertices of a triangle to select it, and then select Delete Selected Faces from the mesh HUD. Poof, gone. With this kind of mesh, you not only have a solid base for your further CG or compositing work, but you also have great means of quality control. We can really see if our track holds up in all areas of the image. To summarize, geometry can be used to establish a real-world scale to your scene by utilizing the whole effects meshes functionality. Lock points are a great way to constrain a manually aligned scene, especially when there is no clearly identifiable ground plane in the image. Adding trackers to your scene after you've already solved it is possible both automatically and manually, but both methods depend on you retaining your blips, which might make your SynthEyes scene file substantially larger. The mesh generation tools are not built for precise modeling, but for generating quick and reliable proxy geometry, which can then be used for both quality control and for use in other applications. Congratulations! You just mastered another essential tool in your Match Movers toolkit. With that, you should be ready for the next major challenge in this course, which will be tracking both a camera and a moving object. That's what we'll do in the next class, and I really hope to see you there.